Thank you everyone for joining us for this webinar, Architectural Lighting Products and Lighting Techniques, presented by Annie Dafni. My name is Laura Lawrence and I'm the Global Marketing Director at Harman. Just a few things before we get started. Everyone on the call is muted to keep down noise levels during the webinar. However, there is a Q&A function where you can submit questions to the presenter and she'll try to answer as many questions as possible. This webinar is being recorded and the link will be made available a few days after this presentation. We do have a number of other webinars taking place over the next few months for audio, lighting, video, and control, and we'd like to encourage you to take a look at the different webinars in our Learning Sessions workshop series on pro.harman.com. We're adding new sessions daily and have over 20 sessions scheduled for August and September, so watch for those coming up on the calendar. And now I'd like to introduce you to my colleague, Annie Dafni, the presenter for today's webinar. Annie has been involved in architectural lighting for 7 years and is currently working at Harman as an application engineer. Having designed many IGBC and GRIHA rated green buildings, she's a strong believer of sustainable living. She uses 3D rendering tools like DLX to visualize her concepts. And now I'll pass it over to you, Annie.
Thank you, Laura, for the introduction. Hi, I'm Annie Dafni. Good evening. And I'm an application engineer for Martin Lights, and I'm based out of Bangalore, India. Today in today's session, we will explore the architectural lighting product portfolio of Martin and also take a sample model and see the different lighting techniques for facade that we can apply using these Martin fixtures. In order to understand the true essence of what this architectural lighting exactly is, let's take an example here. So the first thing that comes to our mind when we look at this structure is that the architect would have put in a lot of effort in designing such a magnificent structure. And during the day, it's completely fine because the sun is beautifully bringing out the color and the texture and the form of the building. But what happens at night? You know, it's completely dark, and so we're not able to see them. We're not able to truly appreciate the beauty of this architecture, and that's when architectural lighting or facade lighting plays a very important role in transforming a situation like this into something as spectacular as this. So you see here the building has got a completely new perspective, and also it looks completely different, right, with this architectural lighting. So this is actually the Mercedes Superdome in New Orleans, and the entire installation has been done using the Martin exterior wash fixtures. So what are the other reasons to light up a building? So in addition to actually increasing the appeal of the building, architectural lighting becomes a marketing factor when you have an iconic structure in the city and you're doing facade lighting for this. It drives in commerce. And for private and corporate buildings as well, it becomes a landmark when you do facade lighting or architectural lighting. And another interesting fact is that that I read in an article is that facade lighting has proven to reduce crime rates in a city because apparently a brightly lit street because of a facade reduces crime rates. Okay. So when I talk about architectural lighting, I need to mention about Dr. Richard Kelly here. So he was a lighting designer himself and was considered as a pioneer in architectural lighting. And it was him that during his term in the early 50s, he actually coined 3 terms or 3 tenets of facade light, architectural lighting, or I would say in 3 philosophies of architectural lighting. So the first one is ambient luminescence. So this basically means illuminating a surface without any shadows or uniformly illuminating a surface. So in terms of facade lighting, we could call it the wash lighting or the flood lighting technique. And the second technique is the focal glow, where you are individually highlighting specific elements on the architecture. It could be a pillar or a column, or it could be the vertical or horizontal fins on the building. So you are deciding what the viewer has to first see when they're looking at the building, and you're drawing their attention to these specific elements. And in this technique, we tend to play with light and shadow. There is a strong contrast between brightly lit areas and dark areas. And the third layer is an add-on layer and a very interesting layer, and it's called the play of brilliance. So this layer actually invokes emotions, I would say, and it has a tendency to make a building very interesting. In the Martin portfolio, we have the exterior projection ranges, which can actually be used for this layer. So if you look at the image to my right as well, you would all agree, or at least most of us would agree, that the building to my right is much more interesting compared to the building to the left because of all these gobo projections. So that is a play of brilliant layer that Kelly was talking about. So what we will do is we will also go through each of these techniques using the sample model that we've created. So the reason I've chosen this kind of a building, which was specifically created for this webinar, is because it has a lot of architectural elements that you can highlight, and also has a good amount of solid facade, which will reflect off light when you're talking about these traditional wash lighting techniques. So like I said, the first technique, ambient luminescence, but when you're talking in terms of facade lighting, I would like to call it the wash lighting or the flood lighting technique. And this is the simplest form of lighting and uses very optimum lower number of fixtures, because you're basically throwing light from a distance or just uniformly washing a surface. And it makes the entire structure actually visible to us, and creates a uniform lux level on the surface as well. And again, very ideal for concrete buildings, which has a good amount of solid facade. Like it could be anything like a church or a statue, temples, monuments, museums, etc. From the Martin portfolio, the exterior wash fixtures, which can either be pole mounted or floor mounted, and the light is thrown off from a distance, and also the in-grounds and the linear fixtures with preferably wider beams can be used for this technique. So let's see what these exterior wash fixtures are. So in the Martin portfolio, we have three variants of exterior in the exterior wash family. So we have the RGBW LEDs, which have discrete individual red, blue, green, and white LEDs, which are distributed like you can see in the image here. And when you mix two or more of these colors, you're going to get different secondary colors. And when you mix all three together, you're going to get white. But we still have individual white LEDs to give a much brighter and a truer shade of white. And this particular distribution, because of the presence of these individual LEDs, it's possible to get tighter, narrower beams, and so very suitable for applications when you need to throw light from greater distances, or when you have to throw height to larger heights. Now, depending on the wattage, we have the 100, 200, and 300 series. So the 100 is a compact 50-watt variant, which is used for small applications. And then we have the mid-range 200, which is a 185-watt fixture. And then we have the extremely powerful 300 series, which is a 280-watt fixture. Now, the second variant is the quad chip LEDs. So like you can see in the image here, there are a number of lenses which are on the fixture, and behind each of these lenses we have quad color LEDs. So what I mean by quad color LEDs is there are RGBW clusters behind each of these lenses. And so what happens is the color that comes out is already pre-mixed before it even reaches the lens. So the final output you get is has superior color mixing and also a very good level of color saturation. Again, this is used in applications where the hues of color or the color mixing or saturation is very, very important. And also an advantage over the RGBW is, since the colors are pre-mixed, what happens is sometimes when you place a fixture very close to the wall, in the RGBW variant, you tend to see these discrete, color from the individual LEDs, and that can be completely avoided in this variant. And also, but actually what happens is because of the presence of these lenses, you will not be able to achieve very tighter beams. So that's when the RGBW version becomes very important, when you need a much more brighter output and the throwing distance is also much larger. Now, the third variant, again, in the quad chip version, we have the 110, 210, and the 310 series, depending on the wattage and size. So the last variant in the wash family is the dynamic white, which is a tunable white variant. And you can change the color temperature from 2700, which is a warmer tone of white, to a cooler 6500 Kelvin. So we have individual 2700 and 6500 LEDs which are distributed on the fixture, across the fixture. So here again, we have the 120, 220, and the 320 series depending on the wattage and the size. Okay. So moving on, so again, not all applications are the same. So we, in order to cater to different applications, we have externally mounted diffuser kits, which will, with which we can achieve different beam angles. So we have ranging from the narrow 7.5, which is without any diffuser. The standard fixture comes with a 7.5-degree beam angle, and then we have diffuser kits for the narrow, medium, wide, and the very wide, which is a 60-degree beam angle. And in addition, we also have the asymmetric lens. So the asymmetric lens gives an elongated oval shaped beam, which is very ideal if you want to highlight a really long, maybe a wall, and you can reduce the number of fixtures because of the oval shape of the beam. And the exterior wash family is also a true permanent, it's very ideal for true permanent installations because it comes with an IP66 rating, and it also has an ingress protection of IK08, and it has a marine grade corrosion resistance rating against rust, because the biggest enemy to any exterior fixture is corrosion due to moisture and salt in the air. And because of this rating, it can be installed in very harsh conditions, coastal areas with a high level of humidity, and also on cruise ships. And the third feature is these fixtures. Each LED on the fixture is color calibrated to give a very consistent color shade amongst the fixtures and also among the LED of the same fixture. So if you have an installation maybe with 1,000 fixtures, all the colors, when you change colors, all the colors will have the same hue or the same consistency in the color. And again, uniformity not only in the output but also in the color shade is very important when it comes to facade lighting. And again, another big enemy for exterior fixtures is glare. So visual comfort becomes very important when you're talking about architectural lighting, because here you never know who's passing by the street, and so we need to make sure that glare control is very important. So we have the snoot and louvers that you can see here, which comes as an external accessory, and they reduce glare to a very large extent. So the snoot is what you can see here to reduce glare from the side angles, and in order to reduce seeing the direct source of LED, we have these honeycomb louvers which can be externally fitted on the fixture. Okay. The exterior wash also comes with an OLED display at the back of the fixture, which can be used for setting up the DMX addresses or changing the fixture configuration. And you can also use them for standalone programming. So you can set up to 20 scenes at the back of the fixture. And these fixtures are also DMX as well as RDM compliant. So when I say RDM, it means remote device management. So though we need a physical connection, a DMX cable from the controller to the fixture, the addressing can be done remotely. So we don't need to go to individual fixtures to set the address. So that happens automatically. And also it's a two-way communication. So in large installations, detecting problems and monitoring the status of fixtures becomes very difficult. So with RDM, the fixtures will send back status reports to the controller, which you can monitor remotely, and also detecting the area where the fault has occurred becomes very simple. So from the maintenance perspective, the RDM is very, very very useful feature. Okay. So yeah, moving on. This is a very good example of the flood lighting technique. And as you can see, there is a very uniform lighting distribution on the cliff here. Probably the only shadows that you are seeing is because of the, the shape and the form of the cliff. And let's, take an example with our sample model. So what we've done is we have done a dialog simulation of our sample model to explain the flood lighting technique. And in the first approach I've taken of, place the fixtures on the pole. So there are two entrances to this building. One is from the staircase that you can see in the front, or from either sides of these pillars. And we tried as much as possible to avoid placing fixtures in any of these areas where people movement is there. So we've taken, for the facade, which is the right and the left wall, we've taken two poles at the extreme ends of the building. And we're using the exterior wash 206 numbers on either side. And we're using different beam angles because the throw distance will be different, which I will, just explain a little more in detail in the coming slides. And for the pillars, again, placing the fixtures on the base here, the offset is also quite less, and again, it would be an obstruction for people walking in. So we've again taken them up on the poles, which are placed on either side of the pillars, and we've used exterior wash 200, 3 numbers for the 3 poles on the right and 3 numbers for 3 poles to the left. In addition, I've used the exterior wash 200 very wide in between the pole here to basically create a backlighting effect. So why this is important is because if this wasn't there, then these pillars would create a very dark shadow on the wall behind, which is not really desirable. And secondly, this backlighting will also create a nice silhouette lighting effect and create a depth also. So the pillars will stand out in front. And for the portion in the terrace, we've used the exterior wash hundreds, 9 numbers, which are placed on the floor of the terrace to create a very soft lighting effect. So as you can see in this technique here, the entire structure of the building is visible and the shadow is also minimal, and we're using lesser number of fixtures. Though we are not individually highlighting the elements, it's creating a good amount of illumination on the surface. Okay, so moving on. Any beam of light is going to be in the shape of a cone. So as we go away from the fixture, this cone is going to diverge, and therefore the spread will be more, and the lux level will also reduce. So we need to be very careful while choosing the beam angles in order to get a nice illumination on the surface. So when the throw distance is less, you need to use a wider beam angle so you get a good spread without any hot spots on the surface. And as the throw distance, or the distance between the fixture and the facade increases, you need to reduce the beam angle, because firstly, the light should be able to reach the surface without spilling too much on the way. And secondly, you need to have a good lux level on the surface, and you need to confine the beams to the within the boundary of the building. To my the left side of the wall, I've used the exterior wash 200s with a very wide beam angle to get a good spread. And in the right portion of the wall, the lower right portion of the wall, the throw distance is much larger, so I've used a wide beam. And similarly, if you notice, the top portions, I've used the medium and the wide angle depending on the throw distances, because if I were to use a wide or very wide there, then I would be wasting too much of light on the way. The light would just spill on the way, and the light that reaches the surface, the lux level would also be very minimal. Okay. So for the poles again, for the lower portion, I've used a very wide beam to get a nice uniform illumination. And for the top portions, I've used a wide beam. So the light reaches the top, but still has a good uniform illumination. So this is a side angle, and we've used 7-meter poles here, 2 for the facade and 2 for the pillars. And the offset is 7 meters and 15 meters accordingly, respectively, as you can see here in the image. And if you notice, the distance between the ground and the fixture is close to 5 meters. The problem of glare for people walking to and from the building who are on the ground floor or even standing on the stairs is very, very minimal. So the factor of visual comfort comes here, where you're not directly seeing the source of LEDs. But there is a bit of a problem for people in the upper floors, because when you're looking out of the windows, you tend to see the direct LED source. So that can be avoided by using glare shields and snoot, like we previously said. And though the glare shield actually reduces the glare to a large extent from different angles, you will still be able to see the LEDs when you're looking at it, the fixture, from a perpendicular angle. And similarly, the snoot will also reduce glare from the side angles, basically. But what happens is, with the presence of the snoot, you need to be a little careful while angling the fixtures, and also see the spread, because the snoot tends to constrict or reduce the spread for the wider beam angles, because it's basically an extension of the fixture. Okay. So like I said, the flood lighting technique or the wash lighting technique creates a very uniform illumination on the surface. And as you can see here, we're getting a good lux level of 125 on the surface, and it's also quite uniform. So when it comes to lux level, there are no set rules or guidelines as like in the interior lighting. So mostly there are recommended lux levels from the NBC for the interior lighting, but when it comes to facade lighting, we just have recommendations and guidelines, but no set rules. So there are a lot of factors which actually we need to consider while deciding lighting for this for any facade. And one such is the ambient lighting condition. So if you have your building set in the amidst a very crowded city which has a lot of street light and lighting from other buildings, then naturally in order to make your building stand out, you need to increase the lux level, and the recommended levels will be more than 100. Whereas if you have a very isolated building or a high rise building where there is no much lighting from street lights or other buildings contributing, then even a very low lux level of 20 or 30 would make your building stand out. So we need to make sure where your building is set and what is the ambient lighting condition that's contributing. And another important factor is the color, texture, and the form of the basically the color and the texture of the facade, because what we perceive is nothing but the reflected light of the surface. So if you have a very dark color on the facade, naturally what happens is, even if you are actually throwing a lot of lumen on the surface, what gets reflected is very less, because the facade itself or the color of the facade itself will absorb most of the light. So we need to when you're designing, we also need to study these the color and the texture and the material of the facade. Okay. So this pole-mounted flood lighting technique again is very used, or most commonly used in lighting up of big, really large structures like statues or monuments and bridges. And in this example, this is actually the statue of Garuda in Indonesia, which has been done using Martin's exterior wash 300s, and the fixtures are actually mounted on 10-meter poles at the base of the statue, and we have used variants of medium and no diffuser or narrow beams. So for the lower portions of the statue, we've used the narrow beams because it gives a good spread and also the light is able to reach. But for the top portions, the medium beam might not be able to reach and give a good illumination level. So we've used the narrow or the no diffuser beams there, so that the light is able to reach those top portions and still give a good lux level. So this is a Dialux simulated image, and this is a real image of the entire installation. And in addition, we also have some exterior projections for the wing to create animation effects here. Okay. So in the previous example, because of the presence of the poles on either side of the pillars, there was an obstruction to the clear view of the building. So that can be avoided if you're actually placing the fixtures are floor mounted instead of mounting them on a pole. Now the poles on either side of the building is not really a big obstruction, but again, the poles which were in front of the pillars was obstructing the clear view of the building. So in this example, what I've done is I've just placed the fixtures at the base of the staircase because there's no enough offset to place them on top of the staircase. And I'm using the exterior wash 200, but instead of using the wide and the very wide beam, I'm using a medium and wide beam, again because the throw distance is much greater now when compared to the previous example. And for the left and right facade, right walls, I'm still using the exterior wash 200s, which are mounted on the pole. Okay. So this is just a side angle, and with an offset of 15 meters, I'm still able to achieve a good lux level of 100 on the pillars with just the exterior wash 200s. Because of the of these RGBW LEDs, you get a much brighter output as well. And generally in the exterior wash fixtures are super efficient, and you get really good illuminations on surfaces, even if the throw distance is really great. So a lot of times what happens is we don't have the provision or the space to actually mount the poles, and in these cases we need to move the fixtures further away from the building, probably mount them on the adjacent buildings or poles which are really far off from the building. So in these situations, we need a really powerful fixture, and that's when the exterior wash 300 can be used. Because here we've used the exterior wash 300, which can give a lumen output of close to 10,300, and I've used 6 numbers. So what you can see is I reduced the beam angle because my throw distance is much larger. So from wide and very wide, I'm using a medium beam, and since I'm using a 300 fixture, I can also reduce the number of fixtures. So instead of using 6 numbers for each side of the wall, I'm using only 4 numbers here, 4 for the facade and 2 for the pillars. And also I'm avoiding having a separate cluster of fixtures for the pillars alone. And as the offset has increased, I'm even taking the fixtures for the pillars and mounting them on the same pole. So with an overall of just 6 numbers on either side of the building, I'm completing the entire facade lighting of this structure. And in addition, I'm also using the exterior wash 200s for the silhouette lighting, and for the top portion in the terrace, I'm using the exterior wash 100s. Okay. So in a lot of cases, again, in locations, in very windy locations, pole mounting would again become a problem, because there are hazards. It might be a hazard for people walking by, because the wind can just uproot the entire pole, and you might also damage the fixtures. So in these conditions, it's always preferable to floor mount the fixtures. And in this example, we've maintained an offset of 28 meters from the building, and I'm actually floor mounting the entire setup instead of the pole. So I'm using the exterior wash 306 numbers, 4 for the facade and 2 for the pillars. Similarly, on the other side, I'm using 6 numbers, and the other remaining areas remain the same. So again, in all of these examples, the floodlighting technique, firstly, the problem of glare still persists at very minimal angles, like when you're looking at them perpendicularly, maybe out of the window. And secondly, for people walking by in between the fixture and the wall, these people might cast a shadow on the facade. So and thirdly, maybe there is no enough provision to place the fixtures at such a far distance from the building. So in order to overcome these 3 cases, the only way is to move the fixture very close to the building and still get a uniform distribution or lighting level on the facade. So in this example, what I've done is I've used exterior wash 200, and I've used a medium beam angle. Now the reason being, I wanted the light to reach up to the top of the building, and only a medium beam angle would be able to go to that height. And secondly, the medium beam has a much more narrower beam spread, and since we are also moving the fixture very close to the facade, I need to use more number of fixtures. So in this particular scenario, your number of fixtures increases, and in this example, I've used 11 numbers for just one side of the wall, and similarly 11 for the other side. But as you can see, I'm still getting a nice uniform illumination. Now, because of the presence of these ledges here, there might be slight shadows about them because of the angle that I'm placing the fixture at. Sorry. So here, if you notice, I've maintained an offset of 1 meter from the building. Now, it is possible to go much closer to the facade. The minimum recommended distance would be 200 meters from the wall. So when you're talking about the lux level, since you're placing the fixtures very close by, what happens is the light is actually in the form of it creates a very nice gradient effect on the surface. So there is no uniform illumination, but the lux level is much more higher at the bottom of the wall, which is closer to the fixture. And as we go away from the fixture, the lux level reduces gradually. But still, you will get an increased lux level of 100 at the top, depending on the number of fixtures and the wattage that you're using. And at the lower portion, you'll get a much brighter lumen output of close to 200 in this case here. Okay. And in this example, if I move closer to this 1 meter offset, what happens is these ledges would, the shadow created by the ledges would be much greater. And that's the reason I'm maintaining an offset of 1 meter. But it is possible to move much closer, up to 200 meters of offset from the wall if you have a nice smooth surface without a lot of these protrusions and pillars and ledges which are coming out of the building. So when it comes to in this, any flood lighting or wash lighting technique, uniformity of the lighting, light distribution is very, very important. And one prerequisite to have a uniform distribution is have overlapping beams, like you can see here, wherein the second beam is overlapping, at least 50% of the first beam. Because otherwise, if you have discrete beam distribution like this, you would end up having areas of shadows and hotspots, or also called scallops. So this is not really desirable. And in order to have a good uniform distribution, overlapping of beams is very, very important. So there is one way to actually reduce the number of fixtures in this particular scenario where you're placing the fixtures really close to the wall, and that is to increase the beam angle. So if I'm using a wider beam angle, my beam spread is going to be much greater, and so I can reduce the number of fixtures from 11 to 8 if I'm using wide instead of medium. But what you can notice here is the light is not able to reach the top of the building as well as it did in the medium beam. And if I further increase the beam angle from wide to very wide, then I can further reduce the number of fixtures. So from 11, I've gone down to 50. I'm getting a uniform lighting distribution, but the light is not really able to reach the top of the structure as well as it did in the previous examples. Okay. So in all of these examples, we were seeing with exterior washes, but a lot of times clients would not really want to see the physical fixture there during the daytime. They would want the installation to be as discreet as possible. So we have the exterior in-ground series, which is the next variant, which are fixtures which will be recessed into the ground. So they combine the benefits of the dynamic wash lighting effect and the discrete installation during the day as well. And during the night, people just enjoy the effect of the lighting. So in the in-ground series, again, we have the 400, 410, and 420, depending on whether they're RGBW, quad chip, or dynamic white series. And they have an ingress protection of IP67 because they are recessed into the ground and they need to withstand stagnant or running rainwater. And they also come with an impact protection of IK10 in order to withstand people walking over it. And they come with the C5M corrosion resistance grading. And they are actually 142 watt fixtures, and they give a very high lumen output of 5700, 4800, and 6600, depending on whether they are RGBW, quad, or dynamic white. Okay. So here again, we have different beam angles for different applications. And with the exterior wash fixtures, we have the advantage of, angling the fixture by just tilting the yoke of the fixture, which is not possible with the exterior in-grounds. So we have two directional beam angle, diffusers here. One is the 8-degree directional and 20 degrees. So what happens is this particular lens will direct the light onto the facade at an angle of 8 and 20 degrees respectively. Okay. So this is an actual demo that was done using the exterior in-ground 400. The height of the building is 25 meters, and you can see the kind of throw that this fixture is able to achieve. So in order to have a clean look, we can also use the exterior in-ground. So this is a simulation of the exterior in-ground 400 with an 8-degree directional lens. And I've used the same 11 numbers because I'm using a medium beam here. And the advantage of this is it gives a very clean, discrete installation during the daytime. And there's no problem even if people are walking over it. Okay, so the next variant in the traditional wash lighting technique is the exterior linear series. So these are linear, sleek looking fixtures like you can see here. And they come in two lengths, the 4-foot and the 1-foot version. And they also have the RGBW, quad chip, and the dynamic white variants. And when you talk about optics, there are two optics that these linear graze fixtures come with. One is the graze optics and the other one is the cope variant. So the graze comes with a narrow, medium and asymmetric lens, and the cope just comes with one wide beam angle of 105 degrees, and it can be used for indirect lighting applications on the facade. So the exterior linear fixtures, they consume about 20 watts per foot, and they have an IP66 rating, IK08, and C5M corrosion resistance rating. And they are also DMX as well as RDM compliant. The biggest advantage of these fixtures is they can be connected end to end in a chain, and also they don't need any extra control boxes or drivers to actually run them. You can directly connect them to the line voltage, and you can power them through that. And also another thing is, since you're connecting these fixtures end to end in a chain, it would be really tedious when in terms of installation if you have to have two runs of cable, one for power and one for DMX signal. So in order to avoid that, we have IP66 rated hybrid cables, which can carry both power as well as data, and one single run of cable would be enough. And they also come with anti-glare shields in the form of louver or this barn type of structure for glare, and they come with an adjustable mounting bracket, so you can tilt and angle the fixture as you desire. Now, since these fixtures are connected end to end, there is a limit to the distance to which the power or the DMX signal can travel, and the maximum number of permitted limit in a chain is 30.5 meters, and including extension and input cables, you can run one chain can be go up to 100 meters. So this is actually a real installation of the exterior linear graze fixture, and you can see that it creates a nice gradient effect. And exterior linear is most suitable for textured walls because it will bring out the textures and the unevenness of the surface, because these fixtures are generally placed very close to the surface that you're lighting up. Okay. So here we've actually done a simulation using the exterior linear graze, and as you can see here, this fixture has a very sharp gradient when compared to the exterior washes. So the lux level starts out really bright at the base of the fixture, and it quickly reduces before it reaches the top of the building. But it can be used, but it'll beautifully bring out the textures. As you can see, the distance between the fixture and the point where the lighting starts is also very minimal. And also it's a very sleek looking fixture, so it really is not a big sore to the eyes when they look at it during the daytimes. So this is a perfect example, I would say, of the flood lighting technique. So we most of us know the building. It's the Burj Al Arab in Dubai, a 7-star hotel, and the height of the building is almost 321 meters and has 60 floors. And we've used the exterior wash series here to highlight this building. And if you look very closely, you can see that there's a connecting bridge between the shore and the building, and all of the exterior washes are actually placed on the floor on the connecting bridge, and the shooting distance would almost be close to 600 meters, and when I'm talking about the stop portion, and the light is able to reach that. So that's how powerful these fixtures are. So this is just a dialog simulation to give you an idea of how the fixtures are placed and how they are angled. So for the lower portions, the 13-degree, which is a little bit wider beam angle, has been used. And for the top portion, because the throw distance is much larger, the 11-degree beam angle has been used. And in order to avoid glare, for people maybe looking out of the building, and also for vehicles coming out of the hotel, the snoot has been used, and the glare shields have also been installed as an external accessory for the fixtures. Okay, so the second technique is the focal lighting, and in this technique you're basically focusing the viewer's attention to specific architectural elements, and those elements could be anything like from a pillar to the curvature of the buildings or columns, fins or jali walls. And again, this is ideal for solid facades. And in this, from the Martin portfolio, the washes and in-grounds with narrower beams, which will really accentuate the architectural element. And also linear fixtures can be used to highlight elements like fins and columns. So here again, in this particular technique, you are uh, creating sharp contrasts between light and shadow, because you will not be able to truly appreciate what light can do if there is no shadow. And that's exactly what this focal lighting technique does. It basically accentuates the facade. So this is our simulation using the focal lighting technique. So the first thing that you notice as soon as you look at the building is that the pillars are individually picked out. So it's creating more of a punch factor. And also these you're creating this nice kind of crown lighting using the exterior grays for the the top portion of the building. And similarly, each of the window sills and the solid facades are individually highlighted. So with this layer, you get more freedom to use more color combinations, and the concept of layered lighting also comes into play. So you can turn off different layers and create more number of scenes using this. And also, because of the presence of shadows and contrast, you will be able to appreciate the true architectural beauty of the entire facade. And also another element is the edges of these entranceways are also highlighted using exterior linear grays. And I'm still creating a backlighting effect using the grays for each of the stories. Okay. So here what I've done is I've used the exterior in-ground series with a narrow beam so that the light is able to reach up to the height of the pillar. And for the window sills and the solid facades on each story, I've used exterior linear grays, the 4-foot version with a wide beam. Similarly, for the crown lighting as well, I've used the exterior linear grays with a wide beam, which are connected end to end. And for the terrace, the top portion of the terrace, I've still used an exterior wash 200 to create nice soft lighting effect. So I'm not sure, in the previous example, we were not really paying attention to the individual pillars which are on either side of the windows. And with this now, since I'm individually highlighting them using the exterior wash 100, the narrow diffusers, immediately your attention moves on to these pillars. So with this technique, you are literally deciding what the viewer first needs to see when they're looking at the building. Okay. And also, like I said, the concept of layered lighting also comes here, and you can play with a lot of scenes. So in this example, we've turned off all the lighting of the windows, and we're just highlighting the pillars and the solid portions of the facade. And then you can further create another layer by just turning off all the grazers and just turning on the washes and the in-ground fixtures with the crown lighting. And then you can create a layer where the entire uh, all the lighting or all the layers are on. So this basically gives the building a new look every time you create a different layer, and that advantage is present in the focal lighting technique. Okay. So like I said, these exterior linear grazers can be connected end to end. So we need an input cable which carries both power and data, and they can be the fixtures can be connected together, or end to end, or they could be in extension cables in between of different lengths, if depending on the installation. And since the maximum permitted length of fixtures in one chain is 30.5, if you're using the exterior linear, the 4-foot, the longer version, then you can connect 25 numbers in one chain, just the fixtures, and including the cables, you can go up to 100 meters. So in this example, the top floor, the third story, has a total number of 24 numbers of exterior linear fixtures. And so we are connecting all of them in one chain. And we're using 1 meter extension cables wherever these pillars are coming. So a total of 42 meters would be used here, and still it's within the 100-meter limit. Whereas in the second story, what happens is the number of fixtures is close to 44. So I need to divide them into the left and the right portion. So I'm combining the ground and the first floor. So in each of these, in the second string, I have 22 numbers of exterior linear with 8 numbers of 1 meter extension cable. And when I'm going from the ground floor to the first floor, I need a longer extension cable. So the 5 meter is also available. And my total length here would be close to 40 meters. And a similar mirror of the happens on the right side as well. Okay. So with the linear fixtures or the focal lighting technique, we're not looking at a very uniform lighting distribution, but we're looking at sharp areas of bright light and shadow. So the linear grays, because they create a gradient effect, like you can see here, the lux level starts out really bright close to the fixture, and then it quickly reduces as we go away from the fixture. But you will still be able to appreciate the beauty of this lighting when you look at it for real. So this is actually a very good example of focal lighting technique. And there are areas of bright light and shadows like in the window portion here. So the portion between the windows are actually highlighted, and then there are dark pockets of shadow between that. So it creates a very nice effect when you're looking at it. Similarly, each of these pillars are also individually highlighted, and then overall you're giving a nice soft lighting at the top of the building. So this is actually the Auckland Museum in New Zealand, and the facade lighting installation has been done using Inrgounds and exterior wash fixtures. Okay. So this is another example of focal lighting technique where you're highlighting the vertical fins of the building using the exterior linear grays. So we've used the smaller 1-foot version, and each of these fins are actually highlighted using them. So again, the first thing that you look at the building is the kind of wave pattern that the lighting is creating. Okay, so the last layer is a play of brilliant layer, and Martin's exterior projections can create very interesting gobo patterns and projections and animation effects on the building. And when it comes to exterior projection, I would say Martin is almost alone in the market. And it has this fixture has the ability to turn any building into an interesting building. So these fixtures are actually, we have two variants, the exterior projection 500 and 1000, and they use analog image projection on the building. So when you're comparing it to video mapping, this particular solution is much more economical because the installation cost as well as the running cost is very, very less. And they are true outdoor permanent, fixtures suitable for outdoor permanent installations, and you can just install and forget. When I'm talking about gobo projections, they are nothing but stencils which come in between the LED engine and the fixture, the periphery of the fixture, and they are stencils which have patterns etched on them. So when the light hits the stencils, the same pattern is actually projected on the building. In order to get crisp image projections, we need to have a very flat field angle. So these fixtures come with a very uniform field angle. So the light intensity from the center of the fixture to the edge of the fixture is almost uniform. So that's how you get like really crisp gobo projections, like you can see in the image to the left. And they are also DMX and RDM compliant. And they come with, they have a burning hours of 20,000 hours. Continuous burning hours. Okay, so the exterior projection 500 comes with a 230-watt LED engine, and it delivers a lumen output of 6100, and it comes with 4 different beam angles. So we need to choose beforehand itself, depending on the location of the fixture and what is the distance from which it is placed from the building. We need to decide on the beam angle. It could be 11 or 22 or 37 or 50 degrees. And then it has a color wheel which has 8 interchangeable colors and 1 open for any color of your choice. And it also has a gobo wheel with 6 rotating gobos and 1 open. And it comes with the indexing and variable rotation. So what indexing means is a lot of times when you need to project logos on the building, you need to make sure that every time you turn on the fixture, the logo is straight and not slant or tilted. So with the indexing option, you can make sure that the logo is always projected straight onto the building. And we also have the animation wheel to create effects like grass blowing in the wind, or water rippling effect, or passing clouds effect. And the fixture also comes with a prism to create a 4 facet or a 3 facet prism, wherein you can split the beam into 4 and 3 respectively. And it also comes with a frost lens to create a soft edged wash effect. Now the 500 has all the features of the 1000. The exterior projection 1000 has all the features of the 500, and in addition, it comes with a much powerful LED engine. It has a 440-watt LED engine and delivers a very bright lumen output of 16,800. And it also has continuous zoom, so you don't need to decide beforehand what is the beam angle that you need. You can change the zoom from 10 degrees to 43 degrees, and also focusing is possible. In addition to the gobo wheels and the animation and the prism and frost effect, it also has full CMY color mixing. What happens is there are these dichroic filters which are present in order to get different colors. So a lot times with the CMY color mixing, it's a subtractive form of color mixing, wherein you're placing filters in front of white light, and different wavelengths are getting absorbed on only whatever color the filter is in is getting passed out. So because of this particular subtractive technique, the intensity of the light that reaches out will be much lesser. So to overcome that, we have an additional color wheel which has true blue and true green colors, and also some pastel colors. Okay. So this is a very interesting project using the exterior projection 1000. And as you can see here, the fixture is placed at least at a distance of 233 meters from the building, because there's a river which is dividing the building and the fixture, and just one fixture was enough to lit up the entire height of the building. So this is the actual gobo projection on the launch day, and you can see that there's a nice pattern that's filling up the entire building. So this is the Dan Hostel in Copenhagen, Denmark. And just to give you an idea of how powerful these fixtures are. Okay. So a lot of time with the exterior projection fixtures, people tend to go with custom gobo designs, because you can choose patterns depending on the liking of what needs to be projected on the building. So the technique that they generally follow for to make sure that there is no spillage of light onto surrounding buildings, and also to have a crisp clear gobo projection on the building, we follow the grid technique. So here you see there's a prototype stencil which has grids and circles and dots, and after deciding on the location and the distance of the fixture from the building, we insert this stencil, and we study how the light falls onto the building. So depending on how many squares and grids and dots fall on the building, the manufacturers, the gobo manufacturers, they manufacture the gobo so that it when you're actually inserting the actual stencil, the light is very much limited to the boundaries of the building, and the angling and the pattern is also very precise. So this image that you're seeing to the center is an actual image which was used on the launch day of the Menzies Ag building in Switzerland, and just one fixture of the exterior projection 1000 was enough. And if you look very closely, you see that each of these trees are also highlighted, so the gobo projection can be that precise if you're using a custom gobo design. So this is actually the San Francisco, California, San Francisco Flower Conservatory in California, where we've used 10 pieces of exterior projection 500. So here again, the 3D model of the entire structure was actually made, and all of the flowers that are projected are actual flowers which are in the conservatory, and even butterflies that visit the conservatory were used. And these images were actually warped and made into stencils, and then they were projected onto the building. So there is a base layer of wash, and on top of that, the exterior projection is an add-on layer that has been used. So this is our sample project where we've just made a gobo projection. So for the left and right side of the building, we've used exterior projection 500, and for the center again we've used exterior projection 500. But what happens is we don't want the projection to go onto the back wall, so the stencil has been custom designed so that the light falls only on the front of the pillars and the ledge portion on top. Okay. So moving on, the last kind of variant in a Martin portfolio is the creative LED. So this is a very new upcoming trend in facade lighting, where you can convert your building facade into a media facade, where you can run low resolution videos and abstract patterns. So in this particular range, we have the Pixlines. So they are LED linear sticks, which are specifically designed for permanent installation. And they come in 3 variants depending on the pixel pitch. So pixel pitch is nothing but the distance between the LEDs. So the closer the distance between the LEDs, the viewing distance, the minimum viewing distance to see a non-pixelated continuous video will also reduce. So in the exterior Pixline 10, we have 10 mm distance between the LEDs. So your minimum viewing distance by thumb rule would be minimum 10 meters. And then we have the exterior Pixline 20 with 20 mm pixel between the LEDs, and the exterior Pixline 40 comes with a 40 mm pixel pitch between the LEDs. And they are RGB, all RGB LEDs, and they come with different variants of diffusers. Clear, flat, square, round diffusers can be used. So since they are actually permanent, fixtures used for permanent installation, we need to decide on the diffusers while placing the order itself. And they can be they can be driven through the P3 controller, which is Martin's proprietary LED video controller, or in other cases they could also be controlled through RDM or DMX when you don't have a video application. Okay, so the P3 controller is a very powerful and ergonomic LED video controller from Martin, and it's compatible with all of Martin's LED products. And I would say this is the most user-friendly LED processor, video processor in the market, because of the real-time visualization of the video mapping using the graphical user interface. So you can basically see, arrange the fixtures just in the same way that they are installed in the facade, and then you can overlay the video from the media server or any laptop, and then the addressing happens automatically and the video will start playing. So we need to be very careful while we are arranging the fixtures and numbering them so that they are in the same sequence that they are installed on the facade. So again, now the signal or the media signal from the controller goes to the power port. So the power port actually will combine the power, the AC mains power and the video signal, and sends the hybrid signal to the creative LED products. For this, we have hybrid cables which are called the BBD cables, which are used to drive these creative LED products. And these products can either be connected end to end, or they can be connected using extension cables depending on the application. So the P3 controller comes in 4 variants depending on the number of pixels or LEDs that it can control. So we have the P350 which can control 1 lakh pixels, and then we have the 150 which can control 5 lakh pixels, and then we have the P3300 which can control 20 lakh pixels. And then for beginners, we have the free PC based software which can control close to 20,736 pixels. So this is just a snippet of the the P3 controller, the PC screen that you can see, the software, where in this image the Pixlines are actually linearly arranged on the the software, and the video is actually playing in the background. So what happens is the addressing automatically happens, and this the facade also starts replicating the video that's playing on the software. Okay, so this is actually a real-time installation using Pixlines. This is Aarhus and Aalborg building in Denmark, and the exterior Pixline 20s have been installed in a very staggered manner here, and abstract videos can be played on them. So the next variant is Ext Dot HP. So this is actually a circular media facade product, which is in addition to using it as a media facade product, it finds a lot of applications in the crown of jewel lighting for high-rise buildings, like the image that you can see to the right, where you're creating this nice crown lighting for high-rise buildings, and these they come in either RGB or cold white LEDs depending on the application, and they again can be driven through P3 DMX or RDM. And they have three diffusers: the dome, the clear, and the directional lenses that can be externally fitted as an accessory. And the next variant is the VC Dot. So they are actually string-based, flexible, direct LED, direct view LED products, which can be used for media facades. And the biggest advantage of this product is that because they are flexible, they can nicely take the shape and form of the building. Unlike the Pixlines. And you can also have a number of custom pixel pitches from ranging from 200 to 200 to 1 meter, and there are three variants here: the VC.1, 4, and 9. So the VC.1 has one LED dot, and the VC.4 has 4 LEDs, and the 9 has 9 LEDs, which gives a much brighter output. And here again, they can be driven through the P3 or the RDMX or RDM or DMX if you don't have any videos that need to be played and you want to do simple color changing. So this is actually this is an actual installation, and if you look very closely, you will notice that the VC dots are actually on the facade, because the installation can be as discreet as possible. And this is the same building during the night where you are actually playing movies on them. So that's the kind of clarity of video that you can get using these fixtures. Okay. So when it comes to glass buildings, we cannot apply the same kind of traditional facade lighting techniques using the wash fixtures. It's a little bit different when it comes to glass buildings. A lot of buildings nowadays are glass buildings. So for glass buildings, we generally follow techniques like contour lighting or perimeter lighting, which will mark the boundary of the building. Or you could use indirect wash. So since we all know that when you actually wash a glass surface, it's not going to reflect off anything. It's just going to allow light to pass through it. So instead, what you do is you highlight the solid facade or the solid wall which is inside the glass building, and indirect you can see the reflected light off of it. And so in both of these techniques, we can use our creative LED fixtures like the Pixlines and the VC dots or the exterior dots, or in indirect wash, you can also use the exterior wash and the linear grace fixtures to create these effects. So when you're doing the contour, the perimeter lighting, the Pixlines or any creative LED products, they're generally used in the DMX or RDM protocol. So here again, we've just taken a sample model to just explain how we can apply these techniques. So this is an entire glass facade. And in the first example, what we've done is we've created a boundary or a contour lighting using the exterior Pixline 40. So I've used the 4-foot version, which is the 1280 version, and I'm highlighting every floor of the building using this. And since they're direct view LEDs, you can actually see the colors, the different transitions that you can make. And again, the possibilities are limitless. You could highlight every floor, or you could only do the top floors, or you could do alternate floors. So when you want to run these fixtures in the DMX mode, then you need to have the DMX signal, which is coming from the lighting controller, and then the power signal comes from the Martin's PSU, or it could even be any external driver. So we have the hybrid adapter, which will combine, it's a Y cable, which will basically combine the DMX signal and the power signal, and then it'll send it to the BBD hybrid cables, which in turn will drive the Pixlines. So here again, we have a limit to the maximum number of fixtures you can connect in a chain. Depending on the exterior Pixline 10, 20, and 40, the table here shows the maximum number that you can connect in a chain, and including extension and input cables, you could go up to 50 meters. So the fixtures here again come with these pigtails. Each fixture comes with pigtails. So if the distance between the fixtures is less than 50 centimeter, you can just connect them using these pigtails without any extension cables. Okay, so in this example, I'm using the exterior Pixline 40, and since you can only do a maximum of 27 meters in one chain, I can connect a maximum of 20 fixtures. So each row here has 40 fixtures, and so I'm not just dividing them into two chains. So each of these strings will be driven by one Martin's PSU. Or you could also, now since I'm using I mean the installation is outdoor, I'm using an IP66 rated PSU, but if you want to place a power supply inside the building, you can also use a DMX power port, which has one input and 4 outputs. So from to each of the DMX power ports, you can connect 4 chains or 4 strings. So these are just different possibilities that you can do of different examples of contour lighting for glass building using direct view LED products. And this is a real-time installation. So this is the visitor center in the Grand Mosque in Abu Dhabi, where the exterior Pixlines have been used to nicely, bring out the shape and form of the structure. And they're you're not playing any videos on them. They're just doing simple color changing here. So another example that you can, another form of contour lighting that you can do is with exterior washes. So if you have a lot of vertical fins on the building, then you can highlight the fins not only with Pixlines, you could also do it with, the wash fixtures with the no diffuser or narrow beam, because they can reach up to the height of the building. So in this example, we've highlighted the alternate fins using the exterior wash fixtures, which are placed at the, the bottom of the structure. Okay, so the next technique is the indirect lighting technique. So if you have a diffused installation with a diffused glass, then you can place these, either linear grazers or the Pixlines or even the VC dots, along the diffused glass on the inside of the facade, and you will see the indirect wash effect or from the outside. So this basically creates a glow from within factor, which can be used for glass facades, provided the glass is a diffused glass and not a clear transparent glass. So in this example, I've used the exterior Pixline 40, along the glass frame on the inside of the building, and I'm seeing this nice diffused light from outside. So this is a real-time example. This is a Horning building in Arena in Denmark, where each of the triangles that you see are inflated, fabric material, and inside those exterior linear quad pieces are actually placed, and you see the nice diffused lighting effect from outside, or you could say that the building has a glow from within factor because of this. Okay. So with this, we come to the end of the session, which explains, where I briefly explained all the lighting techniques, and also covered the architectural product ranges from Martin. So I would like to thank each one of you, for taking time off your schedules to be a part of this session. And over to you, Laura, for the Q&A session.
Hi, I have a guest here this morning who's going to help me with the Q&A. All right, we do have a question here. Does the exterior .HP require a VC feeder?
No, they don't require the VC feeder. Actually, you can run them either by connecting them to the power port or the PSU. But the VC dots require a VC feeder in order to drive them. So that is an important accessory for the VC dots. But the other fixtures can be directly connected to the PSU using the Y cable.
Okay, we have another question. What is your way of thinking on illumination a classical old building? Should I use color or keep it color temp controlled?
Actually, I would say for an old classical building, a CT version, where you're using a variant of a warm white and cool white would really bring out the, would really look good for an old classic building. But again, it also depends on the client's requirement. We need to consider his or her requirement into consideration if they want to do color changing or if they want to just keep it simple and classic with the tunable white variation.
All right, next question is asking, are Martin fixtures available in the Dialux program?
Yes, so we do have the IES, the .IES and the .LDT fixtures, which are available in the photometric segment on the website. So you could just go to the website, and for each of the products, we have a tab, a list of options, and there is a photometric tab which you can click on, and you will get the different, the IES and the .LDT files for the different beam angles.
Okay, next question. For terminating electrical and data connections on in-ground fixtures, can that be done in the fixture or does it require an external junction box?
Yes, we do require an external junction box, which comes along with the, as an external accessory. So we need to make a pit, and we need to first install the junction box, and then the fixture will be placed into it.
The next question, what is the difference between the VC feeder M16 and the BBD based one? Is there an IP rating difference?
I'm sorry, can you repeat the question, Laura? I didn't get that part.
Sure. What is the difference between the VC feeder M16 and the BBD based one? Is there an IP rating difference?
So the BBD cable, now the VC feeder is just an adapter which actually which is used to combine the power and the video signal, and the BBD cables are nothing but the extension or the input cables which are used to carry the signal, which is the already combined signal from the VC feeder, and they will in turn drive the VC dots.
Okay, next question. Are there increasing regulations regarding wildlife, mainly bats? How can we mitigate some of these issues?
When it comes to facade lighting?
It doesn't specify.
Okay. I'm not really sure how to answer this question, but maybe you could, always write to us. I have my, you could reach out to any of us. So Shilpi is actually the techno-commercial lead. And then we have Mr. Vinith, who's also an application engineer, Mr. Edwin, who takes care of the South, and who's an application engineer himself, and myself, you can reach out to. So maybe I could, you could mail us, and I could find out more information about this. But yeah, I would definitely like to know about this myself, do some research on it.
Okay, we have another question here. For terminating electrical, I'm so sorry.
That's okay.
For terminating electrical and data connections on in-ground fixtures, can that be done in the fixture or does it require an external junction box?
Okay, I guess we already answered this, but I'm not exactly sure what else is required. But like I said again, if you could write to us in more detail, I would try to understand the question, and then also ask my colleagues and get back to you on this.
Okay, it looks like that was the last question that came in. Annie's contact information is up on the screen, so if you have additional questions, please feel free to reach out to her directly. And if you're interested in our upcoming learning sessions, you can find those on pro.harman.com. And thank you for the compliment on the baby. This is actually my granddaughter, not my daughter, so thank you very much for that. And thank you all for joining. Annie, thanks for the presentation. We appreciate it.
Thank you, everybody.
Thanks. Have a good day.
Thank you, Laura.